Okay, so I'm back. That's the third part of building this display with the CPU, which may be able to plot points and draw lines. So this actually needs some kind of input, like X and Y, and then it somehow has to draw a line. It's always useful to actually consider what the CPU should be able to build before building the CPU. What the CPU should be able to do. A small problem with that one over there, because I don't know what that one is actually. What that one actually should be able to do. I want that one to be able to do everything. That's bad because I don't have examples of everything. But in this one I want to do line drawing. So the question is, how to do line drawing when given 2 points. Okay, there's this Bresenham. Oh, I don't know how to pronounce that. Maybe I should just look it up and okay, it's Bresenham. I think it's at least written like that. So Bresenham algorithm, line algorithm. I have no clue how that one works. I'm just gonna Wikipedia that. Yeah, it looks quite decent. I've seen plenty of implementations on this server already. I think the last one's actually from the player Manuelos, who's in chat there. But point is, how to do that? How to actually do the algorithm, like in real simple. Okay, here is pseudocode. Pseudocode is awesome because pseudocode is basically the same thing which is gonna be on here, just in more easy. So the pseudocode says, given 2 points, I have to do. I have to take the difference between x and the difference between y. Okay, so far so good. That's quite easy. That's the actual x, y has to go. I should draw that down somewhere in Minecraft. Yay! I have like no clue. Wait, where did I place that block now? Oh well, who cares? Okay, here we got some nice color to draw. Where's the display there? Okay, so yeah, we got a coordinate system. It's really awesome, I know. Don't sue me. So we got 2 points. Oops and burps. And this one, and we got the distance between them. That is in x. It's this. Yep, about that. And in y, it's this. So that's dx and dy, which actually are pretty easy with the simple subtraction to be calculated. So we have 2 points in we have 4 points actually. 4 numbers. We have 4 numbers for these 2 points. And then we got another 2 numbers, which are the difference between them. We're already at 6 temporary variables. We don't need all of them, but that's kind of a lot. And I only have like 7 register addresses, like 7 registers to use. So let's think about it, because before it continues to build that CPU, because it would mess up. So next thing to do is actually to calculate a D. So this D looks kind of dangerous to me, because it takes twice the height and subtracts once the x difference from it. That means that we have kind of a relationship given from this one and this one, these 2 points. And I think the difference in that case is if the rise of this is negative or positive. Like if you have the it's actually directly diagonal to this. That's kind of annoying, because you don't want that case actually to happen. You more like want something like this. That means if you go 1 to the side, the line drops by something, so that's whatever rise value you have, and that is actually in this case below 1. And if you have above 1, things may change, the algorithm changes. For starters, we won't consider that. We'll consider one of these two cases, and we don't even care for the other one. So it's just gonna take the algorithm as is. Point is, we take twice that one, the height, subtract once this one, and then we start with the y position. That is actually the position of this one, of this point. So from this point on, we got some variables. Let's just leave it as is. So what we do now for y is this one, right? But then we also have x, and x starts at this one and goes to here, to this one. So we fill the points from here to here, obviously, because that's a task given. So we go over and do each of the x points. So how to do that? It says from start we just take the y and x we have and just plot that. So we just would plot this point and then calculate whatever we need to make the next one. Recently we calculated in Wikipedia it's d. Actually, I should maybe just copy that over and just show it, but first of all I have to remove all the bookmarks. Okay, there we go. This decode. I have no clue if that's working. I could code it in Java real quick, but I assume that it's working. It's Wikipedia. Wikipedia does never lie, and everything which is in the internet is the truth. So says Abraham Lincoln. Okay, so then we got the d, and the d, if it's bigger 0, then we just take y and add whatever y was plus 1. Doesn't this sound logically? Because we just go up. Right, if d is bigger 0, then we go up by 1 block, so that will be a change in 1. Else we don't. But the thing I wonder is it possible to have like such a strong difference in these two that I have to rise like multiple times up? Oh right, it's not possible. So this code assumes that we will have 1 block per x point between the two given points. So one of the white blocks in between of this, and no more, but no less. So it's just 1, and that's it. And that can either be on the same height or on 1 height above, according to this. And what we do when we did that, when we went up once, we're actually going to remove 2 times the x value from d. Oh, this will be such a pleasure to implement that in the machine code. But from what I see here, we only got multiplication by 2. Multiplication by 2 is straightforward, and it's just addition of that plus that. So it's super easy, it's just twice this one. And then we have to subtract that from d. And then we continue with the next x position. And we're just gonna add dy. Okay, this is kind of interesting because the algorithm is like adding the distance of dy like constantly on top of a temporary variable, and whenever that distance is bigger than 0, we're gonna say, hey, we got 1. We got a rise to 1 up in the coordinate system. Okay, this is the 0, so we got 1. It's plus 1 in this here. This is -1. Oh, this is actually +1. They made the 0 center there and the positives on here. So this would be +1. Now, the question is that... I assume that will work, so let's just assume we have that, and that will work as long as always. It will always work. Yeah, that's good. We can actually do that. So which features do we need? We need comparison. We have to check if something is bigger 0. Important here is the point, it's bigger. We can easily do that. That's simple branching. We have to increment a value. Easy. It's just addition +1. Actually, it would be nicer if we have an incrementation instruction, because there's like only limited amount of registers. So maybe I should really write down like how many stuff we constantly have to keep trace of. I see that after this point, like we never use dx like as a single point. So as is. So after we used it here, we can just multiply this by 2 and save that forever. dy on the other hand is always multiplied by 2. So we will never have to store this one. One can just calculate this and multiply it by 2 instantly. At the next point, one just goes here and adds the difference, subtracts the difference from that. So at this point we got one variable, like here we got two we have these 4. Do we need these? Oh damn, we need these. So we have some x, which is actually x0. So that is like the first variable. Oh damn, I need a text editor. This is going insane. I don't need that. I just need this here. Sublime. OMG, go away. There we go. Why is that still open? Anyway, so let's go. Rex. So we have the first one, which is x0, and then it's x. That is stored anyway. So the next one, which we have, I just named this one current x. The next one which we have is actually the x1, and that is x1, which will then be converted to x. Oh, we always need x1, last x.